Hello, I greet you from Schmölln. My name is Marco Ellenstein. I have been working for many years at the company Indusol in the field of measurement technology and have conducted measurements in various bus systems there. My colleagues and I then found that about 15% of our errors are related to electromagnetic compatibility, and to conduct an analysis of where my sources and sinks of interference are, we use the measuring clamps from the EMCheck measuring clamp case. That means I want to show you what is included in the case. Then I will go into the clamps and also present a few problems that could be analyzed with them. We have 3 different clamps in the case. 2 of them are for measuring currents. One is the loop resistance measuring clamp. With it, we can determine the impedances of the cables. Let's start with the leakage current measuring clamp, which is included in several of our diagnostic kits. With it, you can measure currents up to 1 kilohertz. For that, it is relatively accurate. We have special clamp heads here that filter out a lot of external interference, so we can detect very clear values. If we need to get more specific, like saying we need recordings of potential couplings to specifically identify frequencies, we can then rely on the ISMZ. The clamp has the advantage that we can measure currents up to 40 kilohertz, that we can, of course, measure much larger currents, plus that we can use the clamp through a mode. Can learn for 5 minutes, then set a specific threshold that we want, which exceeds the standard current over this detected measurement period, and then this clamp makes recordings. This means you can make a temporal assignment here, for example, do an analysis with a Profibus inspector and problems that may have occurred in the 24 volt range. Yes, where would we basically conduct current measurements? For us, there are always 5 points. That means first in the area of power supply, then we have the area of potential equalization. Of course, we have the area of shields and shield currents. We have the area of 24 volt supply, yes. And here it is not interesting whether the 24 volts are stable, but rather we have alternating current components on it. And naturally, when working with frequency converters on the secondary side, that is on the motor cables. Now, of course, we have 2 measuring tools with the current clamps that can capture currents. But what if I go to a shield and measure no current there? Nothing at all. Is that good or bad? Yes, that's the big question. So for me, the interesting part is the shield even active? So is it connected, and do I have a loop here? And for this measurement, you use the loop resistance clamp meter. Again, an absolutely simple principle. When you open the clamp, you see 2 coils inside. A current is induced over these coils, which is approximately in the 2 kilohertz range. And through the measurement method, that is through a loop formed with the equipotential bonding and the shield of a cable, for example, one can then determine a resistance or an impedance. Our recommendation is, of course, not more than 0.6 ohms based on the recommended 20-meter loop. But here you have to look in an analysis to say if I even have the possibility of an active shield or not. Well, all in all, that's about it for the tools, especially when you're in areas where you have to expect strong electromagnetic compatibility problems, or working in facilities where more and more frequency converters are becoming relevant. It's advisable to use such a kit to conduct analyses. In conclusion, I can only say, if you have any questions about this, about the clamps, or if you... In conclusion, I can only say, if you have any questions about the clamps or their application, then contact me or my colleagues. Or if you wish, we can also come by, do a measurement together, go through all the clamps again, and conduct an analysis together.